Okay, students, so this week we're going to talk about simple probability. You can also see it as basic probability, so like the beginning of probability. So, an experiment. You've heard this from your science class, right? So, an investigation with varying results. That means that you can have many results, but you're investigating something. An example we use a lot in probability is flipping a coin. So a possible result, outcome could be a possible result. So from the experiment. So when you flip a coin, you can have heads, right, or tails, right? So that's the outcome, whatever you get. In the sample space, where you have two choices, right? So the set of all possible outcomes. In flipping a coin, you have two options, right? You have heads or tails, right? All right. So another thing that we use is like the days of the week. So what would be the outcomes? So you have the day. What's the sample space? So the sample space is all the days, right? So that's Monday, Tuesday, Wednesday, Thursday, Friday, Saturday, and Sunday, right? So how many? What's the number of outcomes? 7 days, right? All right, so what is probability? It's a measure of the chance of a specific event occurring. And the notation that we use is P, it's a probability of an event happening. So that's how it looks. Okay. It is expressed as a ratio of favorable outcomes to the total number of outcomes. So the total number of outcomes will be your denominator in this ratio. This ratio can be written as a fraction, which is normal for a ratio, as a decimal or a percent. The sum of all probabilities in a sample space equals to 1. So we need to remember that. All right, so the first example, it says, give each probability as a fraction in the simplest form. Once we have the ratio, we need to remember to simplify our fractions, right? Always here in probability too. So the spinner below is used in a game. It is spun once. Find each probability. So let's answer these questions here. So what's the probability that it falls on a 9? Notice that it goes from 1 to 16. So there's only one 9, right? So 1 over 16. Now, if you divide that, you get 0.0625, and then multiply by 100, right? So that's 6.25. You can just move that decimal to the right twice, right? To multiply. All right, so what's the probability that you get at least 12? All right, at least means that anything above 12. So that's 1, 2, 3, 4, 5. That's 5 over 16, which is the total. And then you divide 5 over 16. So that's 0.3125. You multiply by 100, you get 31.25%. Okay. What's the probability that you get a perfect square? Well, 1 times 1 is 1, 2 times 2 is 4. Another one would be what? 16 times 4 times 4 is 16, and 3 times 3 is 9. So you have 4 of them. So that's 4 over 16. 4 goes into 16. So 1 over 4. And then you divide. That's 0.25. If you divide 1 divided by 4, and then that's 25%. Okay. What's the probability that you get a non-shaded number? How many are they? 1, 2, 3, 4, 5, 6, 7. So 7 over 16. 7 over 16. You divide that. Oh, you can't simplify. That's already simplified. So that is 0.4375. You multiply by 100, it's 43.75%. Okay, next one. What's the probability that you get a 2 or a 11? Well, there's only one 2 and there's only one 11. So that's 2, right? So 2 over 16, two numbers, right? All right, so you have 2 goes into 16 and then 1 over 8. You divide that, you get 0.125, and then you multiply by 100, you get 12.5%. What is the probability that you get a multiple of 5? All right, so 5 times 1 is 5, 2 times 5 is 10, and 3 times 5 is 15. Those are the three possible outcomes. So 3 over 16, that's already simplified because 3 doesn't go into 16. And then 0.1875 and 1875%. Okay, you multiply by 100. All right. All right, so that is one of the examples that we use. We use a spinner a lot. So let's move on. We have a couple examples here that we can choose. So a month of the year. So we need to know how many months are in a year. We know that there are 12 months, okay? That's something that we have to know here to start this question. And that is our denominator. That's the total months. So how many months starts with J? Well, let's write them up. So that's January, February, March, April, May, June, July, August, September, October, November, and December. Those are the months. So how many start with J? Well, there are 3, right? And 3 over 12. Now 3 goes into 12. And then so 1 over 4. And we get 0.25 when we divide 25%. Okay? What's the probability that a month starts with T? Well, there's no T here, right? So 0 over 12, which is 0%. What's the probability that a month has at least, at most, 30 days? So 1, right? 2, 3, nope. Oh, no. 5, 3, 4, 5. This one, 5. 5. So that's 5 over 12, and then you divide by 5 over 12. That is 0.41767. And then you multiply by 100, that's 41.67%. Okay? I mean, you multiply the decimal by 100, right? All right, so a letter from the word, that's another pretty popular one that we use, letters from words. We have to count how many letters are there. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and 11. There are 11 letters total. That's our denominator. All right, so what's the probability that you get a B? How many B's are here? 1 and 2. So that's 2 over 11. You divide that, you get 0.1818. Multiply by 100, you get 18.18%. What's the probability that you get a vowel? So that's 1 vowel, 2 vowels, 3, 4. So that's 4 over 11. You divide that, you get 0.3636. Multiply by 100, you get 36.36%. And what's the probability that you get a Y in this word? Well, it's 1, right? 1Y. 1 over 11. And then you divide that, you get 0.0909. You multiply that by 100, you get 9.09%. That's another pretty popular one that we're going to see. Now, another pretty popular one is this one. A pencil box contains 5 red, 6 yellow, 8 blue, 3 orange, and 2 purples. The first thing that we have to add them all. Let's add them all. How many pencils are there? There are 24 pencils. And that's our denominator. All right. In the first question we have, what's the probability that you get a yellow? There are 6 yellow, right? 6 yellow. So that's 6 over 24. 6 goes into 24. So 4 times, so that's 1 over 4. We switch that to a decimal, that's 0.25, and then it's 25%. What's the probability that you get blue or purple? Well, you gotta add them, the blue and the purple. How many do I have? I have 8 blue and 2 purple, right? 2 purple, yes. So we add them. So that's 8 over 24. Oh no, 10, sorry, 10 over 24. You divide by 2, that's 5 over 12. and divide that. That is 0.417, and then you get 41.7%. Okay. What is the probability that we do not get an orange? Well, we have to subtract the orange from the total, right? So how many orange are there? We have 3 orange, and 24 minus 3, that's 21. 21 over 24, we divide by 3, that's 7 over 8. And then you get 0, you divide that, that's 0.875, which is 8.75%. Okay. All right, for this one, I need you to know that there is a total of 52 cards. There are 4 suits, meaning there are 4 suits like hearts and diamonds and all that. There are, in the 4 suits, there are 4 queens, there are 4 kings, and all that. So imagine that each of the cards, each of the suits have 13 total cards, right? In each suit, okay? So what is the probability to get a queen? There are 4 out of 52. Red 3. So imagine there's all the cards, right? So like 2, 3, 4, but there would be 2 reds, right? Because there's 2 colors, right? Black and red. All right. And then I'm gonna spade. There are, how many spades are there? Well, there are 13 because that's one of the suits, right? So a queen, there are 4 over 52. 3, there are 2 because there are 2 suits that are red and 2 suits that are black. So 2 out of 52. And then a spade, there are 13 spades, right? So all the cards in one of the suits. Okay. You will need this for later, but just know the basics here. All right, so the complement of an event is the probability of that event not happening, That's the complement. So it's happening or not happening. That's the complement. The complement is not happening. So since the sum of all probabilities its space is 1, then the probability of an event not occurring is 1 minus the probability of the event occurring. So let's look at how that looks. If the probability that it will rain tomorrow is 3 over 8, what is the probability that it will not rain? Well, that's 1 minus 3 over 8. We switch this into a fraction to be able to subtract that, right? So we look at this denominator, that's 8. So that's 8 over 8, which is 1, right? Minus 3 over 8, that gives you 5 over 8, okay? So this is the probability of the event not happening. And 5 divided by 8 is 62.5%. That's the percentage, right? Because you divide 5 divided by 8, and then you get 0.625, and then that's times 100. All right, next one. If the probability that someone will win a game at the carnival is 1 over 24, what is the probability that it would not win? Well, same thing, 1 minus 1 over 24. Well, how do we get this to a fraction? We use this denominator because remember, we have to have common denominator. So that's 24 over 24, which is 1, minus 1 over 24. That is 23 over 24. I'm not going to switch this into a fraction, into a decimal, but you just divide 23 divided by 24. You get this, you get a decimal, and then you multiply by 100, and so on. Number from 1 to 8 is chosen at random. What is the probability that it's not prime? So we need to know how many prime numbers are there between 1 and 20. I already know there's 8. So that's 1 minus 8 over 20, right? And then, well, we do the same thing. So that's, we grab that denominator, 20 over 20 minus 8 over 20 equals, you get 12 over 20. Now you gotta simplify this, right? So that's 6 over 10. Well, you can still simplify. You divide by 4. So that's over 6 and 10. You can do 6 and 10 and then just find it. Okay. That would be 3 over 5 actual. All right, simplification. If a state is chosen at random, what is the probability that it does not begin with the letter M? Well, I already found this, but it's 8 over 50. There are 50 states. So 1 minus 8 over 50, and then you get the denominators 50 over 50 to be able to subtract that fraction, and then you get 42 over 50, and then you divide this into decimal, and you get a percent of 84%. Okay. All right, so that is the complement. All right, I hope this helps.